Welcome to the Algebra 2 lesson from the unit of graphing functions. This is section 6, special functions. We are going to be graphing absolute value functions today. We will also be graphing piecewise functions. And lastly, we will be graphing step functions, specifically one called the greatest integer function. Starting off with absolute value functions. In order to graph an absolute value function, we are going to be making an XY chart. So we're going to graph these. We're going to state the domain and range after it is graphed, and then we will do all of this by creating an XY chart. So f of x, this just means we have a function of f. If it's easier, you can think of f of x as y. So if we make an XY chart, we're going to plug values in for x and figure out what y is, or what f of x is. The way we label our graph is x, and this is our y-axis, or in other words, f of x. You're going to have to start getting used to that f of x notation because eventually we will be 100% in it. You just need to pick some values here for your x's. So I'm going to pick -2, -1, 0, 1, and 2. We're going to take these and just plug it in. So if my x is -2, looking at this function, I have the absolute value of -2, which is +2. When my x is -1, I have just an absolute value of -1, which is 1. When my x is 0, absolute value of 0 is 0. When my x is 1, absolute value of 1 is 1. And when my x is 2, the absolute value of 2 is 2. Now I take these and I just graph them. So I have the point -2, +2, -1, +1, 0, 0, 1, 1, and 2, 2. You now can take a straight edge and connect those lines together and extend it all the way through the graph. Notice that an absolute value graph, this creates a V shape. Okay, so when you have an absolute value function, it creates a V. So that means when you are making your XY chart, you are not done until you get that V shape. This next example will be a good example that illustrates that. So here we're going to graph f of x is equal to the absolute value of x minus 4 plus 2. So we're going to once again just pick some values for x and figure out what f of x or y should be. So if I pick -2 here, I'm going to plug -2 in. So absolute value of -2 minus 4 is going to be -6. Absolute value of 6 is +6, plus 6 or plus 2 is 8. So now I'm going to plot the point -2, +8. Next up, I'm going to plug in -1. I'm now going to do the same exact process for simplifying, except for I'm going to plug a -1 in for my x instead of a -2. So I have the absolute value of -1 minus 4 plus 2. Well, this is the absolute value of -5 plus 2, which is 5 plus 2 is 7. So I'm at -1, +7. All right, and now I will plug 0 in. 0. Absolute value of 0 minus 4 plus 2. Well, 0 minus 4 is -4, which is a +4 plus 2 is 6. So we have the point 0, 6. And I just realized that this graph is not the same size as what my normal graphs are. So I have to adjust these points. So we're at -2, 8, which is actually off of this graph. -1, 7, 1, 2, 3, 4, 5, 6, 7, which is that top point, and 0, 6. There we go. Now we're going to plug in 1. When we plug 1 in here, absolute value of 1 minus 4 plus 2. 1 minus 4 is -3. Absolute value of -3 plus 2 is 5. Notice at this point in time in the last graph, we had already started our upward jaunt. Here we are still working our way down, so we are not done. And we need to keep going until we start until we see the graph flip up. So plugging in 2. So once again, I'll erase this so we have a little bit more room to work. When we plug in 2, absolute value of 2 minus 4 plus 2. Absolute value of -2 is +2 plus 2 is 4. So we have the point 2, 4. Okay, still we haven't switched back up, so we'll plug in 3. Absolute value of 3 minus 4 plus 2. It's the absolute value of 1, which is 1. Plus 2 is 3. So we have the point 3, 3. Still have not flipped back up. Okay, so we're going to keep going, and we're continuing this until we see that V shape. All right, so next step, we'll plug in 4. Absolute value of 4 minus 4 plus 2. Absolute value of 0 plus 2 is 2, so we have 4, 2. Still have not flipped back up, so we'll plug in 5. Absolute value of 5 minus 4 plus 2. 5 minus 4 is 1. Absolute value of 1 is 1. Plus 2 is 3. Now we're at 5, 3. Notice, finally, we have now formed that V shape. So we can stop making our XY chart and we can just plug in our V shape. All right, so there we graphed. Let's now talk about what the domain and the range of these graphs are. Okay, so I'm going to just erase the XY chart so we have a little bit more space to talk about domain and range. So the domain, recall, are all of your values for x. So here, the domain values are what your x values can be. So all the values for x, such that, notice here, this is our x-axis. We can have any value for x we want. No matter where we go on this x-axis, the graph is always existing. So we're going to say x is in the real numbers. Recall that shorthand notation. Our range, however, is going to be slightly different. Our range are our y values. Notice here on the graph, this absolute value is just going up, and its lowest point here is at 0. So our y values have to be greater than or equal to 0. Down here, there's no graph, so our y values can never be negative. Second graph, the domain. Once again, the values for x here is x can be in the real number, because when we're looking in our x direction, we can really have any value for x, or think of it as in the equation. You can plug in any value for x and actually get a solution out. Our ranges, however, are different. Here's our lowest point with this absolute value. That lowest point is at 2. So our range are all values for y, that y has to be greater than or equal to 2. So here we're stating what types of numbers actually do work. Okay, so we need to be very clear when we do that. Okay, so now we're going to graph piecewise functions. Piecewise functions is just a bunch of different functions all put together. So we're going to graph it, and then we're going to state the domain and the range. You can do this 2 ways. First way is you can make an XY chart. If you make an XY chart, you need to make a chart for both of those sections. Okay? That's certainly one way you can do it. I'm going to show you a different way, which is where we focus on one equation at a time. So first off, we're just going to focus on the equation y minus 4. So the equation y minus 4, y equals x minus 4, we're just going to graph that. So here our y-intercept is at negative 4, and our slope is 1, so we go up 1 over 1. And we're just going to put points in all the way across our graph for where that equation is. Now we're going to look at the stipulations. The stipulations is this only happens when x is less than 2. So on your graph, we're going to go to x is 2. This is our x-axis, so here's x is 2. We're going to go find that point, which is right here. We're going to draw an open circle around it. And then we're going to go, the values that are less than 2 are to the left, so this graph is only to the left. All the points that we just drew to the right of 2 we're going to erase because those are not less than 2. Now we're going to look at the second part of the graph, the negative 1. That function is y equals negative 1, which we know is a horizontal line. So y equals negative 1 is this horizontal line here at negative 1. And looking at the stipulations, it says x has to be greater than or equal to 2. So here's 2. So we're going to go down and find our horizontal line. We're going to put a closed circle because it says greater than or equal to. And greater than or equal to would be to the right, so we will fill that line in to the right, and we will erase anything that was to the left of it. So there's our piecewise graph. They are 2 pieces of different graphs put together. Domain. You can find the domain by looking at these stipulations. As long as all x values are included, it's all real numbers. And here all x values are included because we are less than 2 and greater than or equal to 2. The range, you need to actually look at the graph. So the range for this one, we have a horizontal line here at negative 1, so that means y can equal negative 1. Or take a look at where our other line happens. Our other line is just happening at everything less than this point. Well, that point is negative 2. So, or we can have y is less than negative 2, because that line is only happening below the negative 2 part. All right, same idea for our second example, except for this time we have 3 equations, so we're going to graph all 3 of them. First one, we have x. So our function that we will be working with is y equals x. Y equals x, recall, is the line that goes directly diagonal through the center. It has a slope of up 1 over 1, and it has a y-intercept of 0. And this is just for when y is less than -4, so we go find, when x is less than -4. So we go find -4 on the x, we go down to our graph, put an open circle, less than are the values to the left, so we will shade that graph in values to the left. We'll erase everything else. Okay, now we're going to take a look at the middle portion here, which says -3. So the second part of this graph is y equals -3, which we know is a horizontal line at -3. 1, 2, 3, here's my horizontal line at -3. Now we'll look at the stipulations. It says in between -4 and +2 on the x. So here's -4. It is -4 is less than or equal to, so we'll put a closed circle. Goes all the way to +2, so here's +2. Go down and put an open circle there on our graph. And we are just in between those 2 values, so that horizontal line. We will then erase everything else. Okay, and the very third part of this one then, the third part is -3x plus 6. So we will go and we'll want to graph the line y equals -3x plus 6. So it intercepts at 6, has a slope of -3. So down 3 over 1, down 3 over 1, down 3 over 1, down 3 over 1. And this is only when x is greater than or equal to 2. So here's x equals 2. It happens right here. Greater than or equal to is to the right-hand side of it. So to the right-hand side of it, that would be this portion of the graph. And that is a nice filled-in circle because we have that greater than or equal to. We can go ahead and erase the other couple dots we made. So here would be our piecewise function. Now if we wanted to state the domain and range of this, the domain here are x values. Our x can be any real number. Notice that when we look at these stipulations, every single value of x is accounted for. The range here, however, is different. Our highest value here on the range is right here at 0. And notice that we do have a graph that exists everywhere below 0. So here the values for y would be y such that y is less than or equal to 0. Pay attention to the next video for step functions.